Hi everyone. So in this video I am going to start with curved mirror. In the previous video we have studied about light, the properties of light. Then we have studied about laws of reflection by the plane mirror and image formation by the plane mirror. We also studied a very important phenomena called lateral inversion. So today we are starting with the curved mirror. The curved mirror are nothing but that they are a part of a sphere. So in the previous class when we studied the plane mirror, the mirror surface was just plane. Suppose this is the mirror surface, so it was just plane. Now in this case it will be little curved. Okay, how curved mirrors are derived, what are their properties, what are the important points that we have to study in this. So very first thing we will study what are curved mirrors. So curved mirrors are, it is the one which is derived from a sphere having external surface polished. Okay, a sphere, consider a ball, and the ball is actually shining one. You might have seen those balls which are on the disco light and all, you might have seen. Okay, or the Christmas decoration ball which is having outer surface very shining one. So those balls, if you cut it into a small piece, then the curved surface which you get, that is called a curved mirror, or rather you can consider a spoon. Okay, so in the spoon the external surface which is curved, that can be considered as a convex mirror. Okay, so this is convex mirror. Now convex mirror will always have a center of curvature. Now center of curvature is nothing special, it is actually a part of that sphere from which it is derived. The circle, the ball's center point is center of curvature. Okay, so this is denoted by capital C. The next is aperture. Now when a spherical a ball is cut into a piece, suppose this was a ball, now it is cut into a piece. So this point to this point, that is the total what you call diameter of a mirror, is called its aperture. This is the maximum area from when the light can be reflected. Okay, so this is denoted by capital area. See, aperture is the aperture of convex mirror is the entire area from which the light is reflected. Okay, so actually light is reflected from all the shining surface, but the maximum area is equal to its diameter. Okay, focus is, in technically we can say, it is half of the center of curvature. Okay, pole to center of curvature, whatever distance is there, half of that is called focus. But for concave mirror it can be easily understood. If the light is coming parallel to the principal axis, all the rays of light will be meeting on F, or they will be passing from F. Now in case of convex mirror, a ray of light which is coming from the infinity, after falling onto the mirror, it will reflect back into the same medium, but when the reflected ray is extended back, it will be appearing as coming from F. So we'll see in diagrams and we will understand it better in the next coming slides. Now, since focus point is always behind the mirror, in case of convex mirror, it is always behind the mirror. You cannot see focus point. That is why I said it appears to coming from F. It is not actually coming. We cannot see it passing from F. Okay, that is why it is virtual. Anything behind the mirror cannot be seen, that cannot be taken onto a screen. That is called virtual. Okay, so whether it is image, whether it is focus, whether it is center of curvature, or whether it is any other technical term. Okay, pole is the center point of the mirror, of a mirror. Okay, curved mirror, suppose this is the curved mirror, so this will be the center. Okay, so center point of the curved mirror is called pole and this is denoted by P. कोई ऐसा खास काम का नहीं है, लेकिन एक पॉइंट हमको याद रखना है. Principal axis is an imaginary ray which is joining the pole to center of curvature. Now, pole को दिख नहीं रहा है, center of curvature भी हमको दिख नहीं रहा है, so we are just making an imaginary line. We are considered pole is that line, part of the mirror which is the center point, and center of curvature is that part of the mirror from which of that sphere from which the mirror is obtained. So we know those 2 points. There is no such point visible on the visible on the what you call on the screen, on the mirror. Okay, so this is okay. So this is principal axis. So it is an imaginary line. Okay, now suppose this is the sphere. This is a sphere and its outer surface is polished. So this is the center point, and center point is called center of curvature. Okay, so see, this is the center of curvature. Now we'll cut it into a small piece. From here to here, suppose we cut. So this is the cut piece. So now the reflective surface is this one, the black one, this side one, and the yellow one is actually a opaque part. Okay, so this is the surface which is reflective, and its pole, center point, is called pole. And this is the center of curvature, and this is the maximum area from where the light is reflected. From here to here, light is reflected. That is called aperture. Okay, so you understood what is aperture, you understood what is pole, what is center of curvature. Okay, a imaginary line which is joining the center of curvature with the pole is called principal axis. This is center of curvature, this is pole, and an imaginary line which is joining it is called principal axis. Okay, so now laws of reflection padhte hain. Laws of reflection for the plane mirror we have studied. What were those? That is the incident ray and the reflected ray and the normal, all three lies in the same plane, and the angle of incidence and angle of reflection are just equal to each other. Those two laws will be applicable here also. Let us see. A ray of light passing through P and A, that is called principal axis. Okay, so that will reflect it back. Now one thing you must remember, any light which is passing through C, so this is also passing through C. Any light which is passing through C is always perpendicular on the mirror, and all the lights which are perpendicular to the mirror are all behave as a normal, and a light which is falling onto the normal will be reflected back onto the same direction. Okay, so a ray of light which appears to pass from C will return back into the same path after reflection. और जहां से आई वापस उधर ही चली जाएगी. A ray of light running parallel to the principal axis will be reflected in the same medium, but when it is extended behind, it appearing from or it is appearing from F. Okay, और अगर नॉर्मल खींचेंगे उसका C से तो वो उसके बीच में आएगा. तो अभी हम देखेंगे इसको in the diagram. Angle of incidence and angle of reflection will always be same. So let us consider, this is a mirror, pole, center of curvature, focus, principal axis. Okay, 4 terms are clear. Now a ray of light passing through P and A will be called principal axis. ये हमने पढ़ लिया, imaginary ले, ये देख लीजिए, ये इस पे कोई भी लाइट गई वो वापस इधर ही आ जाएगी, because this is acting as a normal. Okay, a ray of light running parallel to the principal axis reflects back in such a way that it appears to be emerging from F. देखते हैं, ये लाइट गई है यहाँ से. अब इसको अगर हम यहाँ पे देखेंगे तो इट इज अपीयरिंग फ्रॉम एफ. देखिए ये तो हो गया इसका नॉर्मल, ये देखिए ये रिफ्लेक्ट हो गया. So this is the angle, this is angle of I and angle of incidence, and this is angle of reflection. And this any ray which is coming from C is acting as normal. तो normal के दोनों तरफ जो भी angle है, angle I will be equal to angle R. And when it is extended behind, it appears to be emerging from F. So this is the only possibility for concave convex mirror. Whether you keep the object at infinity, or you keep it here, or you keep it here, or you keep it here, all the time the image will form. Anytime it will be forming between the F and P. Okay, कैसे बन रहा है अभी देखते हैं. Another line लेते हैं, another ray लेते हैं. that is which is passing through C will reflect back onto C. So C, यहाँ से कोई लाइट गई है C पे गई है, वापस से लौट के आ जाएगी. यहाँ से एक लाइट गई C पे गई है, will reflect back. Okay, so these two are the cases. A ray of light running parallel to the principal axis, after reflection it will go in the same medium. When extended behind, it is appearing from to be it appears to be coming from F. And a ray of light which is falling on the C will reflect back in the same direction. These two laws will be, or these two conditions will be considered for image formation. So let us see image formation through convex mirror. देखते हैं, एक ऑब्जेक्ट रख लिया, से फॉर एग्जांपल यहाँ पर हमने ऑब्जेक्ट रख लिया, दिस इज माय ऑब्जेक्ट, ठीक है. सो नाउ व्हाट हैपेंस, ये पुराना आ गया. When the object is placed on infinity, this is our mirror, this is P, focus and center of curvature, and this is the object. So the ray of light which is running parallel to the principal axis will reflect back in the same medium. When extended behind, it will be appearing from coming from F. तो देख लीजिए, ये लाइट गई हमारी और ये रिफ्लेक्ट हुई है वापस, as if it is coming from F. दूसरा क्या है, यहीं से एक रे निकालेंगे, joining C will be reflected back onto C. ठीक है, and where the two line intersect, the image formation will be there. So here the image is formed. Now whether you keep the object here or you keep it here, or whether you keep it here or you keep it here, image will always be formed between F and P. There is no other option. The image will always be formed between F and P, and this is why this is used as a rear view mirror. Okay, let us see the image properties. What are the properties? Now the location, it is always between F and P. Size, it is always diminished, हमेशा छोटा ही रहेगा. ऑब्जेक्ट कितना भी बड़ा हो, image will always be small. Third, orientation, it will always be erect. And fourth, it will be, since it is behind the mirror between the F and P, so it is always virtual. तो चार important properties हो गई, that is always between F and P, always diminished, always upright and always virtual. Always लिख दिया because there is no other condition. Okay, so ये हो गया हमारा image formation. As the focus and the center of curvature both are lying behind the mirror, so this will always be virtual. Second, uses, क्या काम आएगा ये? It is used as a rear view mirror. Now we have seen such a big object was there, image form was tiny. You all are using automobiles. You might have seen that image which is formed in the rear view mirror is always small. Such a huge truck, but the image which you are seeing in the rear view mirror is always small. So it covers the large area. Okay, so that is why we are using, पहली बात तो क्या है, it is always forming a virtual image, tiny image, that is the diminished image, and it is covering the wide area, and that is why it is used as a rear view mirror. Secondly, it is used to see wider view of an area like a shop and etc. by a manager. Thirdly, it is an ideal for spotting the object in the blind turns. You might have seen there are some cases where the turn is so sharp that you cannot see that what is coming from behind. So in such places, usually government place a convex mirror, a large convex mirror. So any truck, car, bus, auto, scooter, etc. coming from that side, you can spot it on the mirror. So you can be aware that something is coming and how you have to drive. Okay, so these were the properties and nature and uses of the image which are, or of the convex mirror. Okay, convex mirror की ज़्यादा यूज़ नहीं है, जो है वो यही है. अभी हम पढ़ते हैं concave mirror. Concave mirror में क्या होगा? As we have studied, the convex mirror was a part of a sphere which is having external surface polished. In case of concave mirror, it is again a sphere, but its internal surface is polished. Okay, let us see. Concave mirror is a part of a sphere in which inner surface or inner layer is polished. Okay, aperture इसमें भी वही होगा, the total end to end where the light is reflected, this is denoted by A. Pole इसका भी वही होगा, center point of the mirror, that is called pole, denoted by P. And प्रिंसिपल एक्सिस इसमें भी वही होगा, P और C को जोड़ती हुई जो भी लाइन निकलेगी, that will be called principal axis. Okay, so this is the sphere. Now we'll cut it. Okay, this is the sphere having its inner surface polished. काट देते हैं इसको. When such a sphere is cut, it is acting as a concave mirror. काटते हैं, देखिए ये काट दिया. So now the inner surface is reflective, outer surface is opaque. So the inner surface is that this type of mirror is called concave mirror. Okay, ये इसका सेंटर कर्वेचर हो गया इस पूरा स्फेयर का, और ये इसका पोल हो जाएगा. ठीक है, सेंटर ऑफ कर्वेचर. This is the half of the center of curvature, that is focus. ठीक है, half of the curvature is known as focus. This is center point of the mirror, that is pole. So the center point of the mirror is known as pole, denoted by P. So these three important points we are seeing. F is the center of the mirror. Sorry, P is the center of mirror. C is the center of that sphere from which the mirror is derived, and F is half of the C. Okay, and a line which is joining these two is called principal axis. ठीक है, it is an imaginary ray. Okay, अब पढ़ते हैं laws of reflection. Now यहाँ पे अपन को कुछ चीजें याद रखनी है. क्या है? A ray of light running parallel to the principal axis after reflection passes through F. Okay, ये देख लीजिए. A ray of light running parallel to the principal axis after reflection passes from F. दूसरी साइड से भी निकालो any times. A ray of light running from F after reflection will run parallel to the principal axis. Just उसका पहले वाले केस का उल्टा हो गया. F पे से कोई लाइट जाएगी, after reflection it will run parallel to the principal axis. Third, a ray of light running through C will reflect back. C पे से गई, वापस से रिफ्लेक्ट हो गई. ठीक है, you can see. ठीक है, so these three things you have to remember. Okay, एक और हो सकता है, that is a ray light falling on P will be reflected back in the other direction. ठीक है, चलिए ये भी देख लेते हैं. यहाँ से यहाँ पे गिरा P पे, after reflection it will pass into the other direction. So angle I will be equal to angle R, and all the cases it was like that only. If you take this here again, इस C से अगर अपन एक नॉर्मल वहाँ डालेंगे तो एंगल I will be equal to angle R. ओके, सो लॉज ऑफ लाइट रिफ्लेक्शन जो है मिरर वाले वो यहाँ पे भी लगेंगे इक्वली. नाउ पढ़ते हैं इमेज फॉर्मेशन. ठीक है, इमेज फॉर्मेशन थ्रू कॉनकेव मिरर. नाउ image formation through concave mirror are, for the different position this will be different. Let us see. अच्छा, 3 laws अपन ने पढ़े हैं. लाइन कहाँ से जाती है, कहाँ पे. Whenever 2 or more rays will intersect, the image will be formed there. Okay, so there may be many light rays are emerging and falling onto the different points. ठीक है, and wherever 2 lights intersect, the image will form. ठीक है, तो चलिए इसको तो अपन इंटरसेक्ट वगैरह का अपन पढ़ लिया. इमेज फॉर्मेशन पढ़ते हैं, कंडीशन टू कंडीशन. फर्स्ट, इमेज फॉर्मेशन कहाँ पे, व्हेन द ऑब्जेक्ट इज केप्ट एट इंफिनिटी. सो दिस इज आवर मिरर एंड द ऑब्जेक्ट इज प्लेस्ड एट इंफिनिटी. द रे ऑफ लाइट रनिंग पैरेलल टू द प्रिंसिपल एक्सिस विल पास फ्रॉम F, C, and the ray of light which is passing from C will reflect back into the same point, and where the 2 light intersect, the image formation will take place. So farther the position, the tiny will be the image. Closer as you bring, the image size will go on increasing. Okay, because इसको जैसे पास लेकर के आएंगे, the C will, this ray will go on increasing, the angle will always increasing, so the image size will also increase. तो अभी when the infinity हम मान के चलते हैं, if it is infinity like sun, so sun is so far that all the point will meet at F only. वहाँ पे वो इतना दूर भी नहीं जाएगा, it will be just on the F only. Okay, so हम ये मान के चल रहे हैं कि infinity से जो भी light आ रही है, image is always found at F और very close to F. Properties क्या है इसकी? Image properties. The location is at F or it is close to F. Size is point size. Nature is real because you can keep a screen here and you will get the image. Okay. Anything which is this side of the mirror, in front of the mirror, you can get it on the screen. Behind the mirror you cannot get in the screen, that will be virtual. तो ये real हो गया. Orientation, it is inverted. Object हमारा सीधा खड़ा था, image हमारा उल्टा है. Okay. Let us take the second condition. When the object is kept beyond C, ये C है, यहाँ पर रख देता है. ठीक है, ये हमारा object है. A ray of light running parallel to the principal axis will pass from F, and the ray of light passing through C will reflect back onto the C and the image will form at their intersection. So the image is formed between F and C. Now the image is little big, not of the point side, but it is little big, it is inverted, it is real. Okay? So देखते हैं image properties. Location between F and C. Size diminished, not exactly point, but it is small. Nature real and orientation is inverted. Okay. Third case लेते हैं. अब हम इसको कहाँ पर रख देंगे? C पे रख देंगे. When the object is placed at C. So this is our mirror and we will place the object at C. And ये हमारा object. So ray of light passing parallel to the principal axis will come from F. And the ray of light which is passing from F after reflection will run parallel to the principal axis. And देखते हैं कैसा होता है, ये देखिए. And when we'll intersect these two, यहाँ पे image बनेगी. Image is of same size but it is inverted. The image is of same size of object but it is inverted. Okay, बस इतना ही है. तो property देखते हैं. Image properties. Location at C. When the object is at C, image will also form at C. Object is at C, image is also formed at C. Size क्या? Whatever size of the object is that, same size of image is there. ठीक है? So same size of object. Since it can be derived on the screen, so it is actually real and it is inverted. Very important. But इसका कोई practical use नहीं है. Okay? You can take कहीं ना कहीं तो बना ही सकते हैं यूज, बट ऐसा कोई खास नहीं. एंड व्हेन द ऑब्जेक्ट इज प्लेस्ड बिटवीन F एंड C, F एंड C के बीच में रख देंगे तो क्या होगा? यहाँ रख दिया हमने. सो द रे ऑफ लाइट रनिंग पैरेलल टू द प्रिंसिपल एक्सिस विल पास फ्रॉम F, और रे ऑफ लाइट विच इज रनिंग फ्रॉम F आफ्टर रिफ्लेक्शन विल पास थ्रू C. देखते हैं, ये देखिए थोड़ा जल्दी होगा. ये देखिए. ओके, एंड F पे से जो ये, एंड इमेज इज फॉर्म्ड बियॉन्ड C. इमेज इज फॉर्म्ड बियॉन्ड C and it is magnified and it is real and it is inverted. तो देखिए, image property, location beyond C, size magnified, nature real and orientation inverted. So these all situations you should remember. In all these cases the image was always formed inverted. Position kept changing. ठीक है, पहले वो F पे था, between F and C हुआ, फिर C पे आया, फिर C से बाहर निकल गया. When the object is far, the image is formed at C. As object is brought closer, image is formed between F and C. When the object was placed at C, the image was also formed at C. When the object is placed between F and C, the image went behind, after चला गया, sorry, farther than C. अब क्या होगा when the object is placed between F and C? when the object is placed between, चलिए पहले F पे रख दिया, F पे रखेंगे तो क्या हुआ देखते हैं, ये हमारा प्लेस ऑब्जेक्ट हमने यहाँ पे रख दिया. So light will reflect parallel to the parallel principal axis will reflect from the C. और फिर अब यहाँ पे तो C से तो ले नहीं सकते, तो हम क्या कर सकते हैं, P पे ले लेंगे. आने से बनाते हैं, देखते हैं. ठीक है. So it is going much beyond the C and the size is going on increasing. ठीक है. So when the object is placed at F, the image is formed beyond C, inverted, much larger but real. Okay. So देख लीजिए image properties, location at infinity, size is highly magnified and nature is real and orientation is inverted. Okay, clear? All these cases the image was always inverted. दूर रखते हैं तो इमेज बिल्कुल F पे बनती है, पास लाते जाते हैं F एंड C, और बिल्कुल C पे लिया है C पे बन गया, बिटवीन C एंड F थोड़ा सा बाहर निकल गया, और F पे रखा बहुत बाहर निकल गया. अब हमारे पास एक कंडीशन बची है बिटवीन F एंड P. ठीक है, F एंड P पे लेते हैं. So now here is our mirror and the object is placed here. So the ray of light running parallel to the principal axis will pass from F. देख लीजिए, और एक रे ऑफ लाइट को हमने P पे डाला, उसको हमने यहाँ पे निकाल. यहाँ तो they will never intersect because they are going on increasing distance. But if we draw it behind, so it appear to be meeting here. Since such an image is formed behind the mirror is called virtual image. An image is formed behind the mirror. So this will be a virtual image. It cannot be drawn in a screen. आप वहाँ पे स्क्रीन रखेंगे तो नहीं मिलेगा आपको. ठीक है. इसका यूज क्या है, द डेंटिस्ट दांत देखना है उसको तो एक कर्व्ड मिरर डालेगा मुंह के अंदर, दांत के एकदम पास में. सो द टीथ विल बी समवेयर बिटवीन F and P. And the image will be seen in the mirror which will be quite large, and डॉक्टर को बिना एक्सरे लिए ही दिख जाएगा दांत कितना बड़ा है. गुजरे ज़माने की टेक्निक है. नाउ नो डॉक्टर सीज दिस, दे विल ऑलवेज आस्क यू टू गेट एन एक्सरे डन. ठीक है. बट इन ओल्डन टाइम इफ द टूथ हैड एनी टाइप ऑफ प्रॉब्लम दे यूज्ड टू पुट ए मिरर एंड दे यूज्ड टू सी. ठीक है. एक लंबी सी डिवाइस होती थी, उसके एंड पे मिरर लग रहा था, उसको अंदर डाल देते हैं, दे यूज्ड टू सी इट. ओके. सो दिस वाज द यूज. इमेज देख लीजिए, ये आपने देख लिया. सो नाउ यूजेस ऑफ द कॉनकेव मिरर. कॉनकेव मिरर इज वेरी इंपॉर्टेंट. बहुत सारी जगहों पे यूज होता है. कहाँ कहाँ पे यूज हो रहा है देखिए. इट इज यूज्ड इन द सोलर कंसंट्रेटेड फॉर कुकिंग फूड एंड द हाई ग्रेड इंडस्ट्रीज. ठीक है. कॉनकेव मिरर है आपके पास में, और कॉनकेव मिरर के केस के अंदर क्या है देखिए. Okay. Suppose this is a mirror, okay, and the light is coming from infinity. They will all meet at this point. तो यहाँ पे आप अपना प्रेशर कुकर रख दीजिए और यहाँ पे सन के साइड में. So your food will keep getting all the heat and it will start boiling. Okay. So this is how the food is boiled or cooked. ठीक है. दूसरा क्या है, इट इज यूज्ड बाय द ब्यूटिशियंस. अभी आपको आपके चेहरे पे कोई दाग वगैरह नहीं दिख रहे होंगे और वो आपको ऐसे मिरर के सामने लाके खड़े कर देंगे सच दैट योर फेस कम्स बिटवीन द F and P. So you will get a very magnified image in the mirror. एंड आपको ये छोटे छोटे जो दाने वेरी स्मॉल जो भी दाग धब्बे होंगे ना वो काफ़ी बड़े होकर के दिखेंगे वहाँ पे, और आप भी घबरा जाओगे, अरे बाप रे मेरा फेस ऐसा दिख रहा है, ठीक है। एंड देन ब्यूटिशियन जो है कि अब इसका ये ट्रीटमेंट, ये वाला, ये वो दुनिया भर का क्या देंगे। तीसरा डेंटिस्ट का मैंने आपको बताया दिया। चौथा, इट इज द रिफ्लेक्टर्स ऑफ द हेडलाइट। नाउ दिस इज वेरी इंपॉर्टेंट कि द हेडलाइट्स आर देयर, आपका टॉर्च हो, से फॉर एग्जांपल दिस इज अ टॉर्च, so here there is a reflector and your bulb is placed here. So bulb is at F, so जो भी light यहाँ से निकल रही है वो parallel to the principal axis and the light will go parallel and to a larger distance, ठीक है। The same is in case of car's headlight, ठीक है। So car के headlight में भी यही case है। Suppose this is the car's headlight और यहाँ पे बल्ब लगा, सो लाइट हाई बीम पे जो होती है दैट इज गोइंग टू द इंफिनिटी डिस्टेंस लाइक दिस, ओके। सो दिस इज यूज्ड इन द हेडलाइट्स ऑफ द हेडलाइट्स एंड द टॉर्चेस, ठीक है। तो ये भी इसका एक यूज हो गया। तो दीज आर द वेरियस यूजेस ऑफ कॉनकेव मिरर, ठीक है। सो okay, so that's all for this video. हमने सारे कॉनकेव एंड कॉन्वेक्स कर्व मिरर की बात कर ली, वेयर हाउ दे आर द व्हाट आर द टाइप्स ऑफ कर्व मिरर्स, how they are derived, what are the various type of points of the concave and convex mirror, how image formation take place, what are the laws of reflection, etc, etc. So I think it is clear to you. So if you got any doubt in this you can ask me. So लिखा है यहाँ पे देखिए। That's all in this video. Look forward for the next video. So in next video में we will be talking about the mirror formula and then we will be doing some of the numericals, okay. Further videos about the refraction हम पढ़ेंगे। Now keep watching and like and subscribe the video, and अगर आप like करेंगे तो it will be an encouragement for me, and if you find any difficulty you can ask me, if you find any mistake you can tell me, if you have any idea कि sir if you do this it will be better, then I will take your name and I'll tell you कि भाई ये Mr. So and so ने ये suggestion दिया है, and I'll be very grateful for you. That's all in this video. Thank you.